Everyone, today we are going to give you a demo about the database systems implementation course. We are Group 2. We have implemented some extensions for the open source Java based H2 database. We implemented aggregate functions such as median and mode and a research topic adaptive index. So without further ado, let's get started with the demo. This is the entry point for our database. So to save some time, we have saved the SQL queries, which will speed up the demo. So I'll just copy and paste them here. As you can see, I'm creating a table called clothes, which has an ID which is integer type and a primary key. This is the type of clothes, which is a varchar, the price in double, and the size of the cloth in a single character. So this is done. Let's add some clothes to our table. So we have some insert statements that we have saved. That's done too. Let's have a look at the table. Okay, so as you can see, we have some shirt, trousers, t-shirt and so on in a table. The first extension that we implemented is called a median. As you know, a median is it is a statistical term such as mode. A median is the middlemost value in a list of values. So if you have a list of data and they are sorted in ascending order, the median would be the middlemost value in that list. So for example, in our table, if we sort our table on price, so we can do that by the statement. We can see that the price is sorted, and here we have 6 values, so we do not have a middle value per se, but in cases where the number of data items are even, the median value is the mean of the two middle values. So here the third and the fourth value, 20 and 20, so the median would be 20 plus 20 divided by 2. So let's see if that is the case here. Select median on price from clothes. So as you can see, it is 20. So let me update it and show it to you. So we will update clothes and we will set price is equals to say 45, where type, like, let's change shirt. Let's comment this for a while. Okay, so let's have a look. Okay, so we have 45. So now as this is sorted again, the median should be 20 plus 25 divided by 2. Let's uncomment it and let's check it out. So it is 22.5. So that's about median. Mode, on the other hand, is the value which occurs most frequently in the list of values. So for instance, if you have a look at the size column, we see that there are 3 instances of size small. So if we do a mode on size, we should get small. So yeah, so we're getting small. So that's about mode. Let's talk about the adaptive index. So here we have created a hash based index called adaptive index. Firstly, let me show you the indexes that we already have in our system. So as you can see, we have just one primary key on clothes table, which is created by default. It was created on the column ID. So let's create another table, because I want to show you the performance gain of this adaptive index. So let's create a table employees, which has just 2 attributes, employee ID, which is integer type, and salary, which is double. So that's done. Let's add some employees to our table. So this statement here is a loop statement. It adds a million employee records, and this is a very simple statement. Here we are going to give the employee ID as the loop index, and the salary will also be the same. So we'll have values such as 1 1 2 2 3 3 and so on. This thing takes a while. Okay, so that's done. Let's have a look on our employees table. Let's have a look at all the rows. So what I need you to focus here is the time which is taken for the lookup. So for a million records it's going to take a while, so you can see that the progress icon is moving. So let's just wait. In the meantime, yeah, so adaptive index, it is very flexible index. It works on the queries which are redundantly run. So yeah, 329. Let's store this value. Okay. Now let's create an index. Let's comment this. So every time that you create once you create an adaptive index, and every time you run a query on the table, on the column, the index tries to adapt it to increase the performance gain. So here there is a cost on building the index, but the performance lookup is really huge. So we are trying to create an adaptive index on employees, and the table is on the column salary. So that's done. Let's have a look if it is really made. Okay. Okay, so we have my adaptive index which is built here. Okay. Now let's have a lookup on the rows, and I'm pretty sure that the lookup time will be much lesser. Well, the performance gain depends on the frequency of your operation, and as and when which columns are you using for building the index. The example here is very preliminary. Okay, we have it. So you see the output here. Okay. So the output here, there's a marginal gain. You see there's a marginal gain of 283 milliseconds over 329. But as and when the columns are added to the index, or the frequency of your operation on the columns increases, you will have a higher gain. We plan to implement the in-memory caching and adaptive merging based technique to improve the gain here. But this is what we have here. So thank you for watching. Hope we see you next with our future work. Thank you.